In this example, we have Kristen and Anna who are making hats and bracelets. Kristen can make in 1 hour 15 bracelets, or if she instead spends that hour making hats, she can make up to 3 hats. Anna is a bit slower, so in 1 hour she can make 14 bracelets or 2 hats. Right, so the first question asks us, what is the opportunity cost of a hat for each girl and of a bracelet for each girl? So we're going to calculate our opportunity cost of each item for each person. So of bracelets and of hats. I'm just setting up a little table here to help us keep track. And we're going to calculate that for Kristen and Anna. All right, so let's start with Kristen. So for every 15 bracelets she makes, she gives up the opportunity to make 3 hats. So her cost of each individual bracelet is 1/5 of a hat. Right, for Anna, for every 14 bracelets she makes, she gives up the opportunity to produce 2 hats. So her cost of making 1 bracelet is 1/7 of a hat. For every bracelet she makes, she gives up 1/7 of a hat. All right, now let's go back to Kristen. For every 3 hats she produces, she gives up the opportunity to make 15 bracelets. So her opportunity cost of 1 hat is 5 bracelets. Each hat she makes costs her 5 bracelets that she doesn't have time to make. For Anna, for every 2 hats she makes, she gives up the opportunity to produce 14 bracelets. In other words, every hat costs her 7 bracelets that she doesn't have the time to make. So the next question, part B, asks who has an absolute advantage in the production of hats or bracelets and who has a comparative advantage in the production of hats and bracelets. So let's start with absolute advantage. Absolute advantage means that you can produce something with fewer resources than someone else. So in this case, it would be which girl can produce more bracelets in an hour. And we see that Kristen can produce 15 bracelets versus Anna's 14 bracelets. So Kristen has an absolute advantage in bracelets. Also, when we look at hats, Kristen can produce 3 hats in an hour. Anna can only produce 2 hats. So Kristen has an absolute advantage not only in bracelets, but also in hats. Okay, now what about comparative advantage? So comparative advantage is when one producer can make something at a lower opportunity cost or lower marginal cost than another producer. So in this case, we have to look at our opportunity cost table here. So when we look at bracelets, okay, Kristen gives up 1/5 of a hat for every bracelet she produces. Anna gives up only 1/7 of a hat. So in comparing those, we see that Anna has a lower opportunity cost of bracelets. So Anna will have the comparative advantage in bracelets. Okay, and if we take a look at hats, okay, for Kristen, for every hat she produces, she gives up 5 bracelets. For Anna, it's 7 bracelets. So Kristen clearly has the comparative advantage in producing hats. Okay, so this is really interesting. Even though Kristen has an absolute advantage in both items, she only has a comparative advantage in one of the items. Okay, part C asks us to assume a 20-hour work week for both Kristen and Anna, and to graph the production possibility frontier for each of them. All right, so Kristen, we determined, had a comparative advantage in hats. Okay, and we know that the most hats, and then to write an equation describing that production possibility frontier. So let's start with Kristen, and then over here we'll do Anna. All right, so we start by drawing our XY graph for Kristen. So let's put bracelets on the y-axis and hats on the x-axis. It's perfectly fine for you to flip those axes, but then the mathematical equation will also be flipped. All right, so in a 20-hour work week, Kristen can make 20 times 15 bracelets. Okay, so that's 300 bracelets. So let's put 300 up here on the y-axis. And in a 20-hour work week, if she instead devotes all that time to making hats, she can make 60 hats. So 60 over here. And then we combine the two extreme points. Right? If we want to write an equation, we could do it as such. We could say, okay, what is the maximum amount of bracelets that Kristen can produce in her 20-hour work week? Well, at most, she can produce 300 bracelets. Okay? For every one hat she produces, she's going to give up, hence the negative sign here, she's going to give up some bracelets that she could have been producing instead. So what is her opportunity cost of a hat? It is 5 bracelets. Okay, so for every one hat, she gives up 5 bracelets. So this is the equation describing her production possibility frontier. And this equation is really useful. You can find any point along the production possibility frontier. So let's say you want to know if she produces, let's say, 10 hats. How many bracelets can she still produce? Well, that would be 300 minus 50, or 250 bracelets. So if she were producing 10 hats, she could still produce up to 250 bracelets. Okay. All right, let's erase that for now. And we'll turn to Anna's production possibility frontier. So let's draw our XY graph. Again, we'll keep hats on the x-axis and bracelets on the y-axis. Okay, for Anna, in a 20-hour work week, if she makes up to 14 bracelets per hour, she can make a maximum of 280 bracelets in the week. 280, right? So here we're seeing Anna can make at most 280 bracelets. Kristen can make up to 300 bracelets. So again, we see Kristen's absolute advantage. All right, back to Anna. In 20 hours, if she focuses only on making hats, she can make 2 hats per hour times 20 hours. That's 40 hats. So there's 40, and we combine the two extremes. All right, in writing an equation that describes this production possibility frontier, we use the same wording to walk us through the equation. The maximum number of bracelets Anna can produce in a week is 280. And then for every hat she produces, her opportunity cost of each hat is 7 bracelets. So she is giving up, hence the negative sign, she's giving up 7 bracelets per hat she produces. For parts D and E of this question, we're going to compare 2 different possible outcomes. In part D, we're going to look at the production outcome if each of our producers, Kristen and Anna, spend half their time making hats and half their time making bracelets. We're going to compare that to the outcome in E, where each of them would instead specialize in her comparative advantage. Okay, and just a sneak peek, what we will find is the most that can be produced is always when all the producers are specializing in their comparative advantage. So let's take a look. So for a couple of slides you can make is 60. And let's look back and see how many bracelets can she make. At most she can make 280. D, we're going to spend half of Kristen's time making hats and half making bracelets. So Kristen will she'll spend 10 hours making bracelets. She can make 15 per hour, so she'll make 150 bracelets. And she will spend the other 10 hours making hats. She can make 3 hats per hour, so she will make 30 hats. All right, Anna will make, in 10 hours, 140 bracelets. And in the other 10 hours, she will make 20 hats. Okay, so our grand total will be 150 plus 140 bracelets, so that's 290 bracelets. And 30 hats plus 20 hats, that's 50 hats. All right, so now let's compare the outcome when they specialize in their comparative advantage. So we'll have to remind ourselves who had a comparative advantage in what. So Kristen is going to specialize, so she's going to spend 20 hours making, let's go back. So Kristen will make 60 hats. All right, Anna then has the comparative advantage in bracelets, 80. So she will specialize and spend all her time making bracelets. Okay, so this will be the total production of hats and bracelets if they both specialize in their comparative advantage. All right, so how does that compare to when they just split their time evenly between production of both products? Okay, well, we see that they make 10 fewer bracelets when they specialize in their comparative advantage, right? 280 versus 290, okay? But they make 10 more hats, right? 60 as opposed to 50, right? So they lose 10 bracelets, but they gain 10 hats. So to figure out or to show that they're actually better off by specializing in their comparative advantage, we need to demonstrate that this gain of 10 hats is in fact worth more than the loss of 10 bracelets, right? So how much is 1 hat worth? Well, 1 hat is equal to 5 bracelets for Kristen, and 1 hat is worth 7 bracelets for Anna. Right? That's their opportunity cost of a hat. So every 1 hat that they gain is actually worth somewhere between 5 and 7 bracelets. So the loss of 10 bracelets is really not that much relative to the gain in hats. So they are better off. Okay, one way to, or another way rather, to see that they're actually better off, that both of them are better off by specializing in their comparative advantage, is to answer part F of the question. So part F asks, well, if they specialize in their comparative advantage, they can potentially trade so that they can each get a mix of bracelets and hats to then sell at their business. All right, so if we go with this production outcome here where they've each specialized, what is a potential price that they'd be willing to trade for? So we wrote out here the opportunity cost of a hat for each girl, right? So the price of 1 hat has to be at least 5 bracelets. That's sort of the minimum price that Kristen would accept from Anna to give her one of her hats. And then the maximum price for a hat would be 7 bracelets. That would be the most that Anna would be willing to pay to Kristen to get one of her hats. Okay, so we could say, for instance, 1 hat equals 6 bracelets. That would probably be mathematically easiest, although you could go with 5.5 bracelets, 6.5, anything between 5 and 7. All right, so let's say they decide to go with 1 hat equals 6 bracelets. Now we need to pick how many total hats and bracelets will be traded. So let's say they decide to trade 20 hats for a total of 6 bracelets per hat, so 120 bracelets. Okay, so there's trading 20 hats for 120 bracelets. So now let's show what happens to Kristen's overall inventory of hats and bracelets and Anna's total inventory of hats and bracelets when they specialize in their comparative advantage in trade, as opposed to if they had just maintained separate production possibilities. So for Kristen, let's rewrite her production possibility frontier here. The equation we had was bracelets at most is 300 if she's producing on her own, and for every hat she produces, she gives up the opportunity to make 5 bracelets. So graphically, that looked like this. We have hats, we have bracelets, up to 300 bracelets, up to 20 times 3 hats, so 60 hats. So that is her production possibility frontier in what we call autarky, which is a situation where there is no specialization or trade, and producers, or countries in this case, individuals, just produce on their own and don't interact with anyone else. So in our specialization and trade scenario, okay, Kristen ends up with 60 hats that she produced minus the 20 she trades away to Anna. So she ends up with 40 hats. Okay. In return for the 20 hats she trades away, she ends up, although she didn't make any bracelets herself, she receives 120 bracelets from Anna. So she ends up with 120 bracelets. Okay, if we graph this here on her production possibility frontier, 40 hats is about here. And although I didn't really draw this to scale, 120 bracelets will be somewhere like this. Okay, in other words, she's going to end up beyond her personal production possibility frontier. To see that, we can employ the equation we wrote for her production possibility frontier. Okay, so in autarky, if she were just producing on her own, if she were to make 40 hats on her own, at most, she'd be able to make, let's see, 300 minus 5 times 40 is 200. At most, she'd be able to make 100 bracelets. Okay. So at most, she'd be able to make 100 bracelets. But because she specialized in her comparative advantage, and so did Anna, they were actually able to produce beyond their production possibility frontiers. So we end up here instead of here for Kristen. So Kristen is clearly better off from this arrangement where she specializes and then trades with Anna. Let's compare the outcome for Anna instead. So for Anna, her equation for her production possibility frontier was at most 280 bracelets she can make in 1 week. And then for every hat she produces, she gives up the opportunity to make 7 bracelets. Right? So when we graph that, hats and bracelets, at most 280. And then the most bracelets she could make, hats she could make in a week is 40. Okay, so that was from earlier in the problem solution. So now if Anna has produced all the bracelets, okay, but she traded away 120 of them, then what does she have left in terms of bracelets? So 280 minus 120 is 160. Okay, so she ends up with 160 bracelets. And she didn't make any hats, but she ended up trading for them. So she got 20 hats from Kristen. So she ends up with 20 hats. Okay, so something like this. So she also ends up outside her personal production possibility frontier. Now to see that mathematically, again, we employ the equation for her production possibility frontier. So in autarky, that is if she wasn't specializing and then trading with Kristen, if she were making the 20 hats that she ended up with here, then the most bracelets she could make would be 140 bracelets, right? So 140 bracelets. But instead, she ends up with 160 bracelets and 20 hats. So she is beyond her production possibility frontier when she specializes in her comparative advantage and trades with Kristen, versus under autarky, this would be the furthest she could get.